Day 8 notes, applying properties of similar triangles. The next couple sections of notes, this one and then Day 10 notes, I actually like a lot. They're probably my favorite ones out of this chapter because they pretty much create shortcuts for us. And then in Day 10 notes, we're going to look at some word problems, and they're not awful word problems. They're some things that we'll take a look at, but I think they're kind of fun to look at, just different ones that we'll come up with. So, first thing we're going to look at is looking at some shortcuts so that we can stop having to overlap all these triangles and pull them apart and do all that. Now, part of me doesn't want to teach you this shortcut because there's a common mistake that's made, and I'll show you what that is. What we have, though, is if a line is parallel to a side of a triangle, the intersected sides are divided proportionally. What I mean by that is that this over this is congruent to this over this. So we would say AE over AE over EB is proportional to AF over FC. Okay, those are going to be proportional to each other. So if we look at an example, we would say something like, if this is, actually I don't want to mark these like this, that makes them look like they're congruent. If this is 2 and this is 4 and this is 3, then this would be 6. 2 over 4, that's 1/2. 3 over 6, that's 1/2. That's what we're trying to do here. So let's look at a couple of examples, some pretty simple ones we'll start off with. And the nice part about this is it's almost situated so that you can see exactly what your proportion is going to be. So we have 4 over x equals 10 over 15, cross multiply. So we call this 10x equals 60, so x is 6. What I call this is side splitter, okay? Because what it does is it splits up both the sides proportionally. Now, it's called side splitter. It is not called base splitter. It does not work when you have bases. So if I were to get a problem like, let me see where I can draw this. I'll just go right up to here maybe. If I were to get something like this, and I did 4, 8, and then maybe 2, 4, you cannot look at it like that. Or I'm sorry, I don't want to give you the answer for that one. 2 and x, you cannot do 4 over 8 equals 2 over x. It does not work with sides and bases, only just with sides. That's why it's called side splitter. If you want to put a little note here, side splitter, it splits up the sides, not the bases. It won't work. So if you get something like this one here, you need to redraw the triangles completely like we've been doing before. So it only works when you're splitting up sides. If you look at number 2, you might have to turn your head, but we're going to have 9 over 4 equals 10 over, okay, we want to find ET. We need to find this first and then add them up. So 9 over 4 equals 10 over x. Cross multiply. 9x equals 40. So x is going to come out to, that'll be a decimal, 40 divided by 9, 4.4 repeating. So this is going to be about, ET's about 14.4 units, we'll call it. Okay, so again, you're setting up a proportion. 9 over 4 equals 10 over x. Okay. Looking at a little bit tougher example with some factoring that we'll have to do. Excuse me. Given that RA is parallel to GD, so that has to be one of the pieces that we know, solve for x. So we can use side splitter now. So we're going to go ahead and pretty much write it as we see it. Negative 2x plus 1 over x plus 22 equals x plus 14 over 20. Get your parentheses around all your binomials. There's a lot of them. Cross multiply. So we have 20 times negative 2x plus 1 equals x plus 22 times x plus 14. So you get negative 40x plus 20 equals, this is a FOIL, x squared plus 14x plus 22x plus 22 times 14 is going to give you, I believe, 308. So you have negative 40x plus 20 equals x squared plus 36x plus 308. You see an x squared and an x, that means get everything to one side. So plus 40x minus 20. So you have 0 equals x squared plus 76x. 308 minus 20 is going to give you 288. Alright, oops, there needs to be a little plus in there. So we have some bigger looking numbers here, that's okay. We're going to have to factor, so you might have to play with some numbers on your calculator. So x, we know they're both going to be positive, so I'll just kind of mess around. I'm not really sure what's going to work. You guys might be able to figure out before me. So I'm going to try, let's see, try 60 times 16. Nope, way too big. Let's try, I don't know, 70 times, nope, that won't work. Let's try 72 times 4. Oh, good guess. You get good at this eventually. So we have 72 and 4. Okay. So that's going to give us 0 equals x plus 72. 0 equals x plus 4. So x is going to be negative 72. X is going to be negative 4. And let's take a look at our answers. We got to plug them back into our picture and see if they work. Negative 72. Negative 72 plus 14, that's a negative, let's see, 58. Okay? Can't have that. You cannot have a negative side length. Negative 4 plus 14, that's going to equal 10. That one's good to go. So negative 4 would be your only solution there. So that is side splitter. Again, you cannot use it when you have a side and a base, just sides. If you're not sure when you can use it, when you can't, just go ahead and redraw the triangles. You'll get the same answer if you do it that way. Next one, I like to call these the railroad tracks. Right? If you have 3 or more parallel lines intersecting 2 transversals, then they divide the transversals proportionally. What I mean by that is AF is to FE. The ratio from AF to FE is going to be the same as the ratio from BC to CD. Meaning, if this was 2, and this is 4, and let's say this is 5, 2 over 4, that's 1/2. 5 over 10, that would be 10 there. That's how they are divided. So look at some examples. I'll leave that there for you guys to look back to. Find FE and BC given the diagram and the following information. AE, the whole thing from here to here is 14. AF is 8. CD is 12. We want to find FE and we want to find BC. Alright, find FE, pretty much a no-brainer. If the whole thing's 14, that's 8. 14 minus 8 is 6. To find BC, we don't know how to do that yet, so let's give that an X. And again, the way this is set up, it is almost putting it in a proportion for you. So what we would say is 8 over 6 is proportional to X over 12. Cross multiply, so we get 8 times 12, and we're going to end up dividing by 6. So we have, let's see, 6x equals 96. Divide by 6. So x is going to be equal to 16, which is BC. So we would say FE is 6, BC is 16. There's your 2 answers. Okay. Let's look at another one. Solve for x and find the length of AE if AF, again, make sure you label x plus 9, FE 15, BC 8x, CD 30. So you don't have any missing sides, you just need to be able to find x and then find the length of AE. Again, pretty easy setup. It is written there for you in the order you need to put it in. X plus 9 over 15 is equal to 8x over 30. Cross multiply. So we get 15 times 8x is going to give you 120x equals 30 times x plus 9. 120x equals 30x plus 270. Subtract. You guys are probably already way ahead of me. So x is going to be 3. There's one piece of my answer, and then to find AE, I need to plug it in here. So 3 plus 9 is going to give you 12. 12 plus 15 is going to give you 27. So again, they are written almost there for you. X plus 9 over 15 equals 8x over 30. Now, if you wanted to, you could do x plus 9 over 8x equals 15 over 30. That wouldn't change it, but this is probably just easier. Last one, a little bit different. Doesn't quite set up exactly like that one does, but if there's an angle bisector in a triangle, then the intersected segments are proportional to the other sides of the triangle. So what that means is that, let's say this is 3 and this is 6. If this is 5, this is 10. They have the same ratios. So the way we would write that is that AB over AD is equal to BC over CD. They share the same ratios. So we'll put it into practice. Solve for x. If KE is 10, EL is x plus 2, LY is 2x plus 1, KY is 14. Okay, so again, you're just going to make sure you match up your sides. So the way I'll do this is I'll do 10 over x plus 2. So I went from the side to this base side here. 10 over x plus 2 equals 14 over 2x plus 1. So this one you might have to turn your head a little bit as you see it, but again, there's different ways you can do it. I just did it because that's how I see it. You could change it up. Again, cross multiply. 10 times 2x plus 1 equals 14 times x plus 2. See if you can beat me to the end. Distribute. Distribute. So you get 6x equals 18. X is 3. So you'd see is if x is 3, this would be 5. This would be 2 times 3 is 6 plus 1 is 7. You have a 10 to 5 ratio, a 14 to 7 ratio. Those are 2 to 1 ratios. That's what we're looking at again here. Last one. Find MH. Okay. Let's see. Maybe I'll give you guys an extra credit point if you're able to figure this one out. I want you guys to find MH. 2 steps. You're going to have to do it a couple different times. If you can do this and you can put it on your paper with work shown, so I need to see where it's coming from, maybe I'll give out some extra credit tomorrow in class. So do MH, or do number 7. We will go over it together, but again, it's like the ones we were just looking at. You're going to have to do a couple different parts to it, but you definitely can get to MH. I expect some of you to be able to get it, and then we'll finish it off tomorrow in class. Thanks. Have a good night.